Hello dear learners, we are going to study about UV visible spectroscopy, lecture 1. Spectroscopy deals with the transitions induced in a chemical spaces due to the interaction with the protons of the electromagnetic radiation. This result of this is either absorption or emission of that energy by the matter in discrete amounts called quanta or photons. Electromagnetic radiations range from the electric waves of low frequency through the UV rays to the high frequencies X-rays and gamma rays. Maxwell in 1864 proposed a wave theory for electromagnetic radiations. According to him, the electromagnetic radiations are made up of two mutually perpendicular electric and magnetic fields which are oscillating and perpendicular to each other. An electromagnetic wave is characterized by its wavelength, frequency, and wave number. Let us have a glance at some terminology which we come across while studying spectroscopy. First one is wavelength. It is defined as a distance between two consecutive parts of one wave to that of the next, and its symbol is lambda. Like we are seeing the crest from crest or tuft from the tuft, that is called as the wavelength, and its unit is angstroms or 10 raised to minus 8 centimeter or 0.1 nanometer. Another term is wave number. It is the reciprocal of wavelength expressed in centimeters. It is commonly used in infrared region. The next is frequency. It is the number of waves passing per unit per second, and it is measured per cycles per second. And another term is velocity. Velocity is the product of wavelength and frequency of the medium, and its unit is centimeter per second or meter per second. Now let us look the various electromagnetic waves which we come across in day-to-day life. First one is the first one is radio waves, and these radio waves are used for communications such as television and radio. The another is microwaves, which we are having at our home for cooking the food and for satellite communications. The type of the waves are infrared radiations or infrared rays, which are ranging from the wave number 200 to 13,000 per centimeter, and these produce the high thermal effects and are used by the electrical heaters, cookers for cooking food, and also we can use the people in the dark with the infrared cameras. It is commonly used to show the presence or absence of the functional groups, which are specific vibrations, frequencies like C double bond O, amino, hydroxyl groups, etc. The infrared region is further divided into three regions like near IR region, mid IR region, and far IR region. Most useful of these is the middle region, which is also known as fingerprint region. Another type of the radiation is visible light, which is having the wavelength from 400 to 800 nanometers, and it is the visible light where we can see through the day, and it is used in the fiber optic communications. The ultraviolet radiations having the wavelength 200 to 800 nanometer, and they can kill the bacteria that are present in water, hence are used to sterilize the water and safer to drink. It is commonly provides the knowledge about the pi electron systems on the conjugated or unconjugated saturations present in the given compound. It is further divided as the far ultraviolet region and the near ultraviolet region. The most important are the ionizing radiations, and these are the X-rays and gamma rays are the types of the ionizing radiations, and they can knock the electrons from the shell of the atoms, turning them into the ions, and this process of ionization can lead to the cancer also, and gamma rays are used for the sterilization of the food. Now we will see the UV visible absorption spectra. To understand why some compounds are colored and some are not. To determine the relationship of conjugation to the color, accurate measurements of light absorption at different wavelengths in and near the visible part of the spectrum are needed to be studied, and the energies sufficient to promote or excite the molecular electrons to the higher energy orbitals is also has to be done, and it is done in the region called as the electronic spectroscopy. And the various types of the electronic excitations can occur in a molecule, and there are generally 6 types of transitions which are occurring in the molecule, that is from the lowest energy level to the higher energy level, and they are in the range of 200 to 800 nanometer spectrum, that is UV range. As a rule, what happens, the energetically favored electrons get promoted to the highest occupied molecular orbitals, and from the highest molecular orbitals to the lower unoccupied molecular orbitals. The resulting species is called as excited state. Excited state is also called as singlet when the spins of the electrons are paired, and triplet when the spins of the electrons in the excited state are parallel. Triplet state is of lower energy than the excited state, and it also takes some more time from coming to the ground state, and it is useful in the spectrophlorimetry. Normally, the absorption of the ultraviolet and visible light results in the singlet ground state to the excited singlet transition state. These are the various transitions which are being observed when the atoms or the electrons are coming in contact with the electromagnetic radiations. These are sigma to sigma antibonding transitions, N to sigma antibonding transitions, pi to pi antibonding transitions, N to sigma antibonding transitions. Let us see about sigma to sigma antibonding transitions. An electron in the bonding sigma orbital is excited to the corresponding anti-bonding orbital. The energy required for this is very large. An example of this is methane, where it can undergo only sigma to sigma anti-bonding transitions, and absorption is at 125 nanometer. And the absorptions cannot be seen or observed by using the typical UV and visible spectra. Then another is N to sigma antibonding transitions. The saturated compounds containing atoms with the lone pairs are capable of N to sigma antibonding transitions, and these transitions are usually require less energy than sigma to sigma antibonding transitions, and they can be initiated by the light of the wavelength 150 to 250 nanometer, and most number of the organic compounds are giving N to sigma antibonding transitions, and another is N to pi antibonding transitions and pi to pi antibonding transitions. Most of the absorption spectroscopy of the organic compounds is based on the transitions of these two types, where there is a need of unsaturated group in the molecule to provide the pi electrons. This was all about the various type of the transitions. Now the solvent systems which are used for the UV spectroscopy. This is the list of the solvents which are used in the UV spectroscopy, and this is the references. Thank you students, thank you learners. Stay home, stay safe.